Hi, welcome to this new lesson that will complete the details of data architectures presented before. So in this lesson, I will talk more about data organization. So the question is how to organize your data. To think about this question, we can take an example of data storage on a distributed file system. So let's imagine we have a project that will last for at least 2 years. And the question is, how do you organize this storage? You may think about storing all this data for these 2 years in a single location. It works technically, but what if you need only to process 2 previous days? So in that case, you will need to read all the whole volume of data, filter out the rows older than 2 days, and possibly the amount of filter rows will represent kind of 90% of the data, and the whole input lecture will be maybe the biggest bottleneck of the process. Whereas if you organize this data differently, for example, in daily subfolders, subdirectories, you may directly target the data you want to read, so the 2 last days, and hence eliminate completely the filter on the date, because as a consequence the filter is applied in the input directory definition. So that's a small trick that may optimize these jobs, and is also the reason why it's very important to think not only about the data architecture, so the components, but also think about data storage and data organization. So how you will organize your data in order to use it efficiently in the jobs, but also in the data exploration or data analysis. So the first organizational unit is called data lake. So data lake stores the history of the data. It's like the master data set we saw in the previous lesson about architecture. So we have the storage that may come from different sources, and that will generally represent and store only the raw untransformed data. So in my example, you can see that I have a data lake storage that integrates real-time and offline data and organize them in subdirectories to know the type, because you may imagine I will have a batch of jobs that will only need the offline data, and on the other hand I might have another batch job, but this time that will be responsible for reprocessing the real-time data. And inside these subdirectories I have the organization per year, month, day, and hour. So obviously it gives you plenty of scheduling possibilities. You can process data per hour, per day, per month, per year, and you can also even imagine weekly processing scenarios, because you can identify the Monday and Sunday of each week to process. But data lake, as I said, is mostly for raw data, for untransformed data. To complete this picture, this data organization layer, there is another proposal called Medallion architecture. So the Medallion architecture organizes data per purposes. So the raw data is called here bronze. This bronze layer stores raw data without any transformation, as it was read and retrieved from the input. To complete it, so you see it already, it's not that useful for the business applications, for the business jobs. To complete this layer, we have 2 other layers. The silver one that is an enriched and improved version of bronze. So this improved version can contain some data enrichment. It can contain, for example, some reformatting, put into conformity for various things like dates. If you have dates expressed differently in your, for example, offline data producer, you may use the silver layer to keep them consistent, to expose data in a single way. And later you have the gold, that is the ultimate layer, where data is used by the business users, by data analysts, by data scientists, and they generally find it useful to create dashboards or machine learning models. And besides this more, I would say, data organization, also data storage oriented approaches, there is another one which is more organizational. So this data approach is called data mesh. Data mesh favors data ownership in dedicated data teams. So you can imagine a data team which is responsible for users, data team B responsible for orders, transactions, team C responsible for maybe products, delivery tracking, and things like that. And all this is wrapped and managed by a single data platform team, providing the best practices, resilient solutions, deployable templates for commonly repeated jobs, and things like that. And the goal here is to make all this team independent. So you can imagine one team having the Medallion architecture, another using pure data lake, another one any other architecture, another team with Kappa architecture but without the master data set. So it's a kind of the idea is kind of decouple them and keep them working together throughout a common metadata layer, so data catalogs, data contracts that are quite new concept as the time I'm recording this video. So yeah, it's more organizational approach where the teams are responsible for their data products, so like maybe tracking, analytics, PC users, smartphone users, orders, transactions, and they need to collaborate and expose and be responsible for the data they are working on in order to make it profitable to the whole organization, to other users that may need to reference the data set they own. And generally a quick recap for this presentation, for this lesson. To remember, there are two ways of data organization: technical, so how to store the data on your storage, and also organizational, so how to make the teams collaborate. Of course, data mesh, it's one of the examples. If you have a small team, you will not necessarily create different teams for with one purpose. You will maybe delegate this product ownership for different products rather to the whole team. So it will depend on the use case, but data mesh is one of the examples of organizational data layer. So thank you for being here with me, and see you in the next lesson.